Hello and welcome again to the Ruby Refactoring series from the tennis game example, Refactoring Kata. We are somewhere in progress of implementing certain test scenarios. We're really not that far, and the code resulted in quite a number of classes, and this is an explosion of classes actually. And we've been going back and forth between different ideas, so once again, I want to throw another idea to try. No, we're here to learn and to experiment, not to finish. No, I'm trying to finish this. Anyway, when I was looking at this code, and right now all the uncommented tests are passing, and there is certain duplication. So while I really like the idea of polymorphic classes, they have the same API. I am afraid that we are doing some duplications here. And when I was thinking about it, it came to my mind that we can think about it a little bit differently, at least try and see where it goes. Like everything in this example, in this series is about different kinds of experiments and learning more and more about our requirements. So the idea is that maybe what we have here are not really objects. Like I explained that already in other videos. This is the actual object. Everything below is an implementation detail. But we are using objects like this at smaller scale to implement the details. But what if those things are not really objects, but they're more like data structures? So representing code as data is not a new concept. I haven't invented it, unfortunately. It's quite a popular thing among many different paradigms, object programming and functional programming, where you just extract a certain piece of code and treat it as data. You can put it in the database or configure it as basically as data because there is no behavior. And maybe we are close to calling this data structures. So where I'm getting here is that maybe what we want to have, and I'm not sure about it, but let's see. Maybe I want to have a result class. And so for now, I can try, should I go with result or should I go, well, okay, just for the sake of keeping the same API here, let's create a new object. And what I want to have is score, player one score, player one result maybe, and player two result, with the meaning that after they score, this is the result. And what we are doing is okay, so here's the class, and then what I need to have is I need to return the score, and I need to I could probably use those struct things, right? If it's a data structure, but I know this will disappear. This class is just temporary. Okay. Still nothing changes here. So instead of having those different results, what if I use that win for player, whatever it's used, it's actually result. And sorry, what was the name? Win for player one. So let's see if I can remove this. Oops. And let's pass nil. I know this is wrong. You shouldn't pass nil, but just for the sake of having this implemented, does it work? Yes, it works. So I can remove this class, right? And now what I can do is I can try and replace other stuff like that. So the result, as I said, the result implementation, the result object is actually later what I want to have instead of result is I would like to have a tuple. From Python, a tuple is just something like that. But in Ruby we can probably just use a list. So instead of I just want to have this representing the result win for player one. So basically this is data, right? So this is a list. It's a tuple, but it's a list. And we can have a list like that. So for example, whoever was using this, okay, so 40love is, could be represented as, this string and then this as an argument. So let's see. I just want to show this example. So there's some string, and then there is this for the player 1 score and maybe nil for the player 2 score. So basically the idea is that we will be building this structure. And while the result elements are very easy because they're just very simple data structures, what we will be building later, so that's for the next video, we will need to build not a tree actually, because our data structures, they would allow cycles. So this will be a graph, right? So this is where we can go with this code. We can try to implement it. We can try to extract all the flow from here and think about it as data, and more precisely as graphs. And at the first step, we can treat it as graphs just in the code. So this will be like, this will be the whole results graph being something like this. And then we can extract it and, just for the sake of example, put it to the database, and then using the database, we can actually manipulate what are the flows, which will be weird because for tennis games, probably the flows can be easily hard-coded in the code, but just to show that this is something possible. So, probably in the next video, we'll try to explore this area further. And then once we have like this, instead of game score, we would have something like result 0, right? And here will be like result first element and second element. Actually, second and third. Yeah, it's 0 indexed. All right, thank you for watching. I hope it was interesting and inspiring to see that we can treat code as data. I remember when I first attempted to refactor one piece of code using this technique, it was quite eye-opening for me. And I was really proud of myself because it reduced like so much data, and I just moved it somewhere to data storage. And basically, we love to remove code, right? So this techniques allow it. So representing code as data, and welcome to the Lisp world, probably.